let's talk about phase shift and how to calculate that when you are looking at a graph of a function. So let's kind of go through all of the high points here. I will be asking you to do the same things that you normally do on these equations. So you need to be able to identify the amplitude, the period, all that good kind of stuff. But also, we're adding the phase shift to that. So let's review all the other stuff first. And I will also be telling you on these questions when there is a phase shift of which function you need to be looking at. So notice that it says cosine up here. And if I don't tell you which one you're looking for, it may be a little bit confusing. So on this first one, we're going to look for a cosine curve. So cosine normally starts up high at a maximum. And so it looks to me like right here would be the beginning of our curve. And if we follow this cosine curve, it looks like it ends here at 3 pi over 2. All right, so that's the window that we're looking at of this function. So let's go ahead and figure out these pieces that we need to know. We need to know what the amplitude is. And remember, that's just your distance from your midline. So let's actually find that first. Here's your midline. It is at 0. So your equation for that's going to be y equals 0. And we are trying to write the equation for this line in the end. So let's see. What about the period? Let's skip that right now. Let's go back to the amplitude. So it looks like it's just one unit. Here's 1 on the axis. So amplitude is 1. Everything's good. So A is 1 so far. D is going to be 0. So what is the period? All right, here's where it gets a little hairy when we start introducing a phase shift. Now, how do you know this has a phase shift? Because it's not starting at 0 or on the axis like it normally does. So when there has been a phase shift applied, you can look at this a couple different ways. All right. Where does the cosine curve normally start? Well, it normally starts right here at 1 on the y-axis. But where has it gone? It has gone back. It's backed up a little bit to where now that point that normally is on the axis is at negative pi over 2. So that is your phase shift. It is a negative pi over 2. Phase shift is a horizontal move left or right where the graph has shifted. So it is going to be in terms of pi when we write that. Now that we've figured out that, let's go back and actually answer the question of what is the period of this function. So technically, period is defined as the horizontal distance it takes on the x-axis to travel from the start of a curve to the end of its cycle. So where does it start? It starts right here at negative pi over 2. And it ends right here at 3 pi over 2. So the period is really the distance from that first point at negative pi over 2 to that last point at the cycle at 3 pi over 2. Well, if we're looking at a regular old number line, let's say we're looking at a number line 1, 2, 3, 4, 5, and I say, how far is it from 1 to 5? Well, how would you figure that out? 5 minus 1, right? So it's the same thing when you're dealing with pi's. It just looks gross, but we're going to do the same thing. We're going to take our ending point minus our start point. Okay, so end minus the starts. And that would tell you where it is. So if you put it in the calculator, what it's going to do is it's going to change that to a plus. That's going to be 4 pi over 2. And what does that reduce to? Still 2 pi. So the period is still 2 pi because we did the ending point here minus the start point right here. And it told us the distance on the x-axis. All right, so let's go back and kind of figure out what these other values are going to be. We know A is 1, D is 0 from the midline. If the period is 2 pi, what is your B value? Just a 1. And then the phase shift, that's going to be a little bit of a different thing. All right, our phase shift is from the formula negative C over D. So what I would do is set these two things equal to each other to find out what C is going to be, because we need that value in our equation, because now we've added a new dimension to it. Now we're looking at it like this. Okay, so we've got parentheses introduced. So what did we know about this? Let's see. We know that the D value is, that's C over B. All right, we know that our B value is 1. and we still don't know C. So what we're going to do is just plug in what we know and then solve this for C. So both of those will become positive. To me, it looks like C is going to be a positive pi over 2. So what is your equation? I'm running out of space here. Your equation is going to be y equals, your amplitude is 1. That's your A. So 1 times the cosine in parentheses B, which is 1, so x. C is a positive pi over 2. And then the midline was 0, so we just leave that as is right here. All right, so let me pop over to Desmos and I'll show you what it looks like. Here it is, right here. Okay, so you can see that we start at negative pi over 2. We've shifted left, still a period of 2 pi. Everything's relatively the same. All right, so we just really need to make sure that we understand how to get that C value is what I'm guessing is going to be a problem. All right, so let's do one more. All right, and this time I want you to look at sine. I want you to find the sine curve where it starts and where it stops. Normally sine starts on the midline. All right, well, where is the midline? Looks like it's going to still be here at 0. So our midline is y equals 0. And if you know the midline is 0, you know that your d value is also 0. And remember, we're working off this equation now. All right, and there is a phase shift here. It looks like the sine curve is starting here and it wraps up at 5 pi over 2. So that's the window. That's the little screenshot we're looking at for this curve. All right, so what is the amplitude based on this? Looks to me like it's still 1. Thank goodness this is still easy. This part is. Okay, now what's the period? How did we do it on the other one? We took the end point on the x-axis minus the start point. So 5 pi over 2 minus pi over 2. Just like a little fraction question here. 5 pi minus pi is 4 pi over 2. Keep the denominator the same, remember, because the denominator is a common one. So your period is still 2 pi. Do you know what B is based on that? Should be a 1. All right, so let's figure out the phase shift. Okay, it looks to me like this graph has been moved to the right. Normally sine starts right here, doesn't it? But it looks like that whole graph has been shifted to where now it starts at pi over 2. That is your phase shift. It is a pi over 2. Now it's the phase shift, but it's not got the value we need to put in that equation to help show what it is going to be if we were to look at it. So we need to figure that out. All right, so I set the phase shift equal to negative C over B. And I did make a mistake on that on the first one. Try to correct it. Hopefully you caught that. And then let's fill in what we know. Well, B is 1, so let's just change that to a 1. And then let's cross multiply. So that would be negative 2C equals pi. We're solving for C. So C is going to be a negative pi over 2. So our phase shift is pi over 2, but our C value is negative pi over 2. And remember in Algebra 2 when we talked about how functions move left or right, and in the parentheses it's always different of what you think? It's one of those type deals. So that sounds a little familiar, hopefully, to you. All right, so the equation is going to be y equals, the amplitude is 1, so A is 1. Sine of B is also 1. So x, and then C is negative pi over 2, and D is a 0. So here's what your equation looks like. So overall, let me hop back over here to Desmos, because what I want you to see is this, okay? When you have a phase shift that says positive, where did the graph move that we looked at? It moved here to here. That's the screenshot I showed you. So a positive phase shift inside the parentheses means we moved left. On the sine curve, normally it starts at 0, but it shifted over to start at pi over 2. So a phase shift, when it shows negative in the parentheses, it moves the function to the right. Just keep that in mind.